density function. So PDF. Okay. Again, let's recall the definition of PDF for one single random variable. So remember, the PDF is defined as the derivative of distribution function with respect to its realization. Oh, just derivative. Okay. On the other hand, the joint PDF, the joint between x, y, will be defined as the partial derivative of joint CDF with respect to both x and y. In other words, again, if we use lowercase for PDF, x, y, random variables, x, y, defined as a partial derivative, okay, of this joint PDF with respect to x and y. Okay, so this is the definition of this joint PDF. And we are going to see this will be a much better function to model two random variables. Okay? And also remember we talked about how we can derive CDF, right, for one single random variable. Of course, we can still do so with two random variables, but the calculation will be much more messy. Okay, so we're not going to spend so much time to talk about this, process. Instead, we're going to focus on, only on PDF most time. For example, how we can determine all those average values, and how we can determine, like say, probability, and so on. Okay, and also later when we talk about, like say, random signal, random process, we're going to also rely on PDF instead of CDF. Okay. So this basically represents. Oh, and here, even though we can also talk about say discrete, random variables x, y, and here just to make our life easier, we are going to only focus on continuous random variables, okay, x, y. All right. So basically, we can finish talking about chapter 3. Like chapter 3, 4 sections, 1, 2, 3, 4. Okay. I guess I can finish next week, and then in the remaining 3 weeks, we can talk about random signal process. Okay, engineering stuff. All right. Okay, so this is the definition. Let's take a look at a few examples regarding how we can some properties as well. For example, for the one single random variable, we know if we do integration from minus infinity to infinity, and then it should be equal to what? What's this result of the integration? 1, right? And now we also have similar result. The difference is instead of single integration, we're going to have what? Double integration. So in other words, we're going to have this property here. Say fxy, xy equal to what? 1, right? Okay? And that's how we can summarize this property. And we can just take a look at, and also remember, to determine a probability like something like this, doesn't matter equal sign or without equal sign. Let's with equal sign here. If we want to determine this probability, then we can evaluate integral from what? x1, x2, right? This will give us this result. Okay. Now, when we talk about, say, two random variables, so you can see here, the event actually corresponding to instead of interval, we are going to have what? A region, right? You see here, this represents a region. For example, we might have, like say, an event.